Just as we can have a probability mass function for discrete random variables, we can have a probability density function for continuous random variables. We could even have a probability function where some random variables are discrete and others are continuous, but that's for later. The key principle is that a sum is an integral and an integral is a sum. For example, suppose we have random variables x and y have PDF for all x and y greater than or equal to 0 and f of xy equals 0 otherwise. Let's figure out what that constant is and find a probability. Since xy can take on any non-negative value, then we want the probability that x and y are somewhere between 0 and infinity has to be 1. This corresponds to the integral, where our region is the first quadrant. Now, there's no obvious preference for direction of integration, so we'll evaluate this as... We can rewrite this double integral as... Then, evaluating our first integral, we get... And so our integral becomes... Computing the second integral, so we find this probability that x and y are somewhere between 0 and infinity. Well, that's supposed to be 1. Our integral gives it a value of 4c, and so c itself is 1/4. We want to find the probability that x is greater than or equal to 2 and y is less than or equal to 2. So we can express that as the integral over the region. And we can rewrite this. And evaluating our first integral. And since this is a constant, we can remove it from the integration. Evaluating our second integral gives us how about a different continuous PDF where we're looking at the probability that a sum of random variables is less than or equal to 1. So again, we can evaluate this as a double integral, but this time we're looking at the region where x plus y is less than or equal to 1. Now, since we want to do this in the hardest way possible, we're not going to draw a graph. Wait a minute, who wrote that? No, we do want to draw a graph because that'll make things a lot easier. So we have our x and y axes, and the region is going to be where x plus y is less than or equal to 1. And so we have our boundary curve x plus y equals 1. And since our x and y values have to be non-negative, that region is going to correspond to this triangle. And so our integral becomes evaluating that first integral gives us evaluating the second integral gives us and so we find our probability will be